So, how do you find the leader of a criminal empire? Especially when that leader is doing everything they can to stay invisible. Well, today we're going to dig into this really cool idea from network science that helps investigators do exactly that. Pinpoint the true kingpin, even when they're hiding in plain sight.
This is the absolute central challenge for any investigator trying to take down a criminal organization. Because in these kinds of secret networks, the people you actually see, the ones making all the noise on the street, they're almost never the ones with the real power. So the big question is, how on earth do you map out a power structure when the most powerful players are actively trying to stay in the shadows? I mean, these people build layers and layers of protection around themselves, right? They're insulating themselves from all the risk, which makes them practically impossible to find using the usual old-school methods. All right, so the first thing you might think of is, hey, let's just play a numbers game, right? Who has the most connections? Just count them up. In network science, there's a name for this. It's called degree centrality. It's basically just a simple head count. But as we're about to find out, it's a total trap. It can lead investigators completely down the wrong path. Think about it this way. A low-level operator, maybe a street dealer, could be connected to dozens of people. That gives them a really high connection count. But the real leader, the kingpin, they might intentionally have just a couple of direct links, using their lieutenants as buffers. They're totally insulated, they're protected, and they're way, way more powerful.
So yeah, just counting connections, it completely misses the point. It's the classic case of quantity over quality. And look, when you're trying to dismantle a really sophisticated operation, making that mistake, it can derail the entire investigation, for sure.
Okay, so if just counting connections is a dead end, then what's the answer? What does work? Well, we need a smarter, more sophisticated way to look at the network. One that gets that real power isn't about the raw numbers. It's all about influence.
And this is where a concept called eigenvector centrality comes into play. It all boils down to a really simple but super powerful idea. It's not about how many people you know. It's about who you know. Your importance is literally defined by how important your connections are.
Let's really think about what that means for a second. It's kind of this circular idea. Influence isn't some fixed number, right? It's more like a current that flows through the whole network. If you're connected to a powerful person, well, that makes you more powerful. And in turn, you make your connections more powerful. It's this constant feedback loop of influence.
I mean, to put it as simply as possible, having one single, direct line to the kingpin is worth way, way more than having dozens of connections to a bunch of low-level players on the street. It's not about the quantity of your links. It is all about the quality.
Okay, that all sounds great in theory, right? But how does this kind of abstract idea actually work in the real world? How do investigators take this concept and turn it into a practical tool they can use to map out a criminal network?
The answer, and you might find this surprising, actually comes down to a single, pretty elegant math equation. Now don't worry, we are not about to dive into a linear algebra lesson. The key thing to get here is that this little formula lets us calculate how the very structure of the network, that whole web of connections, actually determines the influence of every single person inside it.
So the whole process kicks off by building something called an adjacency matrix. Really, the easiest way to picture this is just a giant spreadsheet for the whole network. It's a simple grid that maps out every single connection, who talks to who works with who. This becomes the raw data, the actual blueprint of the entire organization.
Okay, so once you have that blueprint, a computer basically goes to work. It runs this process over and over again. It starts by giving everyone in the network a starting score, say a 1. Then in round after round, it updates and tweaks each person's score based on the scores of their neighbors. This keeps repeating, letting that influence we talked about flow through the network until the scores stop changing and finally stabilize. And what you're left with is this beautiful, clear, ranked list of who has the real influence.
And this right here is the moment where all that theory becomes a seriously powerful weapon for investigators. It lets them zero in on the true heart of a criminal organization.
What this method is absolutely brilliant at is cutting through all the noise to find what you could call the shadow leaders. See, these aren't the foot soldiers out on the street. They're the advisors, the fixers, the brains of the operation working behind the scenes. And the key thing is, they often have very few direct connections, which makes them totally invisible to the old ways of doing things. But make no mistake, they are the ones pulling the strings.
And that's exactly why finding them is so critical. As this quote points out, these people are the organization's human capital. They have the specialized knowledge, the essential relationships, the critical skills, all the stuff that you just can't easily replace.
And that's the real strategic genius of it. You take out just one person with a high eigenvector centrality score, and you can literally fracture the entire network. It cripples the organization's ability to even function. It's a much, much more devastating blow than just arresting a dozen low-level guys who are going to be replaced by next week anyway.
But of course, no single tool is ever a perfect silver bullet, right? Eigenvector centrality has its limits, and actually, understanding those limits is exactly what led to the development of even more powerful and probably more famous methods of analysis.
So, the classic version we've been talking about, it works best when connections go both ways, like a friendship. It starts to run into trouble in what are called directed networks, where influence only flows one way. The perfect example is Twitter. You can follow a celebrity, but they definitely don't have to follow you back. In a network like that, someone with 0 followers would get an influence score of 0. And the problem is, that 0 can then ripple through the network and incorrectly wipe out the scores of other people too.
So to fix these kinds of issues, new algorithms started to evolve. Some, like one called Cat Centrality, did something really simple. They just gave every single person a tiny base level of influence to start with. That way, nobody gets stuck at 0. And this kind of thinking, this evolution, it kept going. And it led to one of the most famous algorithms in the entire world.
And that algorithm? It's Google's legendary PageRank. Yep, it is a direct descendant of the exact same idea we've been talking about this whole time. But instead of analyzing criminals in a network, it analyzes websites. A link from a big, important, trusted website acts like a powerful vote for another site's credibility. It's the exact same principle. It's who you know, just scaled up to organize the entire internet.
So, from flushing out hidden kingpins to organizing literally all of the world's information, the core principle is exactly the same. It reveals this fundamental truth about how interconnected we all are, that real influence isn't just about you. It's written into the very structure of your connections. Which really just leaves one final question to think about. What does your network say about you?